Hello and welcome, my fellow physics mortals. We're going to go over the mechanics solver program, TI84 calculator program, available at mcstutoring.com. So without further ado, let's go over some momentum questions. That's option 4 here, momentum. And we have three basic submenus here, P equals mv. P is momentum, M is mass, V is velocity, and impulse, J is impulse. Don't don't flame me. I didn't make up the equation, I'm just showing you what it is. And then F is force, T is time. And then conservation is for, I think, collisions, things like that. So without further ado, let's get started. Baseball with mass of 0.15 kg is thrown at 35 meters per second. So we've got a mass here, so that's going to be our M. And then 35 meters per second is our velocity. So it's going to, and it's asking momentum, so that's the unknown, so that's the P. So we're going to choose option 1. And then we're going to solve for P. And again, you could solve for any one of the missing variables here, any of the unknowns. So here we'll solve for P. And then, okay, what is the M? It's 0.15. And then what is the V? Velocity is 35. And make sure units are cool, like kilograms, meters per second type of thing. And then we get the momentum is 5.25. And the units there would be kilogram meters per second, or kilogram times meter per second. Okay, and then question 2, a force of 4 newtons, so that's going to be F for force. Atom ball for 0.3 seconds, that's going to be your time. So look, again, I'm not trying to be mean to physics professors and teachers, but they will do things like put this in minutes or hours, and just recognize that you need to convert to seconds here. So this is going to be an impulse question. And again, we could solve for any of the variables. In this case, we're trying to solve for J, which is impulse. And then the force is 4 newtons. And then the time is 0.3 or 0.3, either way will work. And we get 1.2 newton seconds. That's going to be our answer there. Okay, I'll box the answers to make it a little clearer there. Okay, and then we go down. And then question 3. A 1,500 kilogram car moving at 20 meters per second collides with a 2,000 kilogram car initially at rest. After collision, the first car moves at 8 meters per second. So just a note here, because I was wondering, like, hey, how do people know which one to do? If you see both initial and final velocity, so you have the final velocity of the first car here, you'll need the full conservation equation. So we're going to go to option 3, conservation, 1D meaning like 1D collisions, I believe. So we have M1 V1 equals M2 V2, full conservation or collision. So in this case, we're going to do full conservation, I think. And then we're trying to find the second car's final velocity, so that's going to be the V2. And be careful how you enter the units here, because sometimes I switch like mass, velocity. Sometimes do mass, velocity. So just be aware when you're entering the units. So M1 is 1,500 kilograms. And then V1 initial, that's V1I, is 20 for 20 meters per second. And then M2 is the 2,000 kilogram. And then V2 initial is at rest. Oh, and then at rest means something special in physics. It means velocity is 0. Okay. And then the V1 final, the first car moves at 8 meters per second after the collision. So that's going to be 8. Okay. And then, so we get the initial momentum, final momentum, blah, blah, blah. And then V2 final, that's what we're looking for. This is just a conservation type of thing of momentum. But then after the collision, the V2 final, V2F, is 9, so 9 meters per second. Okay, we continue, and then we'll go down a little bit. Oops, down here, I mean. Question 4. 1 kilogram ball moving at 6 meters per second. Oops, let me get there. Collides elastically. Okay, so we got a collision going on, and it's elastic. And then let me explain that for those unfamiliar. If you're familiar, go ahead and fast forward a minute or so. But for those unfamiliar, elastic means like they bounce. Like imagine 2 billiard balls, like if you're playing pool, or if you're in the UK, you're playing snooker. Balls bounce off each other. That's elastic. Inelastic means they stick together. Okay, so just, I don't know, like a hard ball hitting, I don't know, like a clay ball, like, dude, they'd stick together instead of being an inelastic collision. But in any case, this one's going to be elastic. My explanation might not be so good, I apologize. So M1 is going to be 1 for 1 kg. M2 is 2 for the 2 kg. The V1 initial velocity of the first ball initially is 6. And then velocity, remember at rest means something special in physics, means 0 velocity. Okay? So the V1 final is -2. It's going basically 2 meters per second back whence it came. Because in elastic collisions, say we have like this 1 kilogram ball hitting a 2 kilogram ball, it's going this way. Sorry, it's not a great animation, but you got this small ball hitting a big ball. It's gonna, after the collision, it's gonna bounce backwards. Like this ball, like, okay, so that's V1 it's gonna go back whence it came, like the ball rock, and then V2 is gonna move a little bit that way, just so you know how that happens. Okay, so I'm not quite like car collisions. Those tend to be more inelastic. They stick together typically. Not always, they bounce. I don't know. I'm not a CHP officer. Okay, initial kinetic energy, final kinetic energy, yada, yada, yada. Okay, so good. We're through those now. Let's go on to question 5. 4 kilogram cart moving at 3 meters per second collides and sticks. Oh, sticks, man, we got an inelastic collision going on here. So it's going to be a collision, and it's going to be inelastic because it sticks. Okay. Now, and they're going like say this red ball goes and hits this orange cart or whatever, moving the same direction, and in the end they're sticking together. So now they're like the green, which is, I don't know, a combination of red and orange is probably not green, but forgive me, and it's going to be going in the same direction there. So let's say the mass 1 is 4 for 4 kg, and then mass 2 is 2 kg, and then V1 is 3, and then, oh, it's moving in the same direction. So it's moving in a different direction. It would have a different sign. So if this is positive, that would have been negative, but they're moving in the same direction, so they're both positive. So 1. Okay. So VF is 2.33 repeating meters per second. Okay, fantastic. My goodness, we're making progress. We're on question 6, I think, of 8 questions here. Okay, oops, sorry about that. That's not quite where I want. A 15,000 kilogram train car moving at 10 meters per second catches up to and couples with a 20,000 kilogram car moving at 5 meters per second. Okay, so think of an action movie where you've got like one like freight train, or I don't know, like not a freight train, but like these are trains. Here's some train tracks, right? And they're moving in the same direction. But this one, I'll call this 1 and this 2. 1 is moving faster, so it's going to couple. So that, what does that mean? It means it sticks. That means that it's an inelastic. We got an inelastic situation here for a collision. So it's inelastic if it sticks, right? So M1, 1500, or 1500, my bad, 15,000. Check the zeros here, 3 zeros here, 3 zeros here. I think we're cool. M2, oh man, that's 20,000 kilograms. Okay, I hope I have the right number of zeros. V1 is 10, and they're moving in the same direction. If they said opposite, one of these signs would be negative. So V final is 7.14, and I did check that. I put this for me here to check because I thought something was wrong. Okay, in any case, we're going to move on. Question 7, the penultimate question. Okay, a 5 kilogram cart moving at 6 meters per second collides with a 2 kilogram cart moving at 3 meters a second in the same direction. After the collision, they stick together. Oh, okay, so we got conservation, 1D. It is a collision, and it's inelastic because they stick. Okay, so M1 is 5 kg. M2 is 2 kg. Again, be careful because I'm sorry I switched up the masses and velocities when asking, or the prompts for the program here. V1 is 6 meters a second, and V2 is 3. And then so final velocity is 5.14 meters per second. Yay, we got it right. Good. The final question, number 8. Oh, and this is great. Okay, so a 3-kilogram ball moving at 4 meters per second collides elastically. Okay, we know it's a collision and it's an elastic. So elastic collision it is. So conservation, collision, and elastic. Okay. Boom. So M1 is, the mass 1 is 3 kg, and mass 2 is 2 kg, and velocity 1 initial is 4 meters per second. And then initially at rest, oh, that 2 kg ball, the second object, 0, that's what at rest means. Okay, so V1 final is 0.8 meters per second, and V2 final, 4.8 meters per second. Okay, if you're just here to see how it all works, you can stop. But for other folks, if you go on the site, or sorry, first, yada, yada, yada. Like if you like it, dislike if you dislike it. If you have any constructive criticism, put in the comments. I have a link to the program there. If you do go to the site, mcstutoring.com, that's M as in Mary, C as in Charlie, S as in Sam, and then put your name in a mailing list. I know, more emails, right? But I do post coupons and whatnot. Not coupons, God, what a thing of the past. I do post discount codes now and again. So if you do sign up for the email list, you'll get that. And then if you do buy the program, this is the physics mechanics solver. You get free updates. So if you buy it now, every time I make a correction or addition or change, you'll get it. So don't worry about that. Okay, take care. Good luck in all your physics and other related academic endeavors. I'll catch you next time.